Well, welcome. I'm going to tell you a little bit about relative velocity. You'll get a lot of the other details from the book, but this will help you at least get started on relative velocity. Okay. First of all velocities are relative to another object. So if you say, for instance, the speed limit is when they tell you that you can only go 65 miles per hour on the highway, they mean relative to the earth or to the road. They don't mean relative to other cars. To another car, you might be going 0 miles per hour or maybe even 130 miles per hour, depending on which car you're referencing. So let me first tell you the notation for giving relative velocity. So if I want to know the velocity of object A relative to object B, we write it like that, and we'll put a vector here because velocity is a vector. And this is the velocity of A, of object A, relative to B. It turns out that if you want to know the velocity of object B relative to object A, it will be just the opposite of that. So the velocity of B with respect to A is going to equal the negative of the velocity of A with respect to B. If you think about that, if you're approaching a car, another car, and you're in a car, the other car is going to see you going the other way. So that's why you get the negative sign there. Okay, now let's say that you know three different velocities. Let's say you know the velocity of A with respect to B. That's a known. But you also know the velocity of B with respect to C. And you also know the velocity of C with respect to D. Well, it turns out that to get the velocity of A with respect to D, let's say if we wanted to figure that out, you just add these vectors up. Remember, they're vectors, so you got to add them like you add vectors. But the way you do it is you have to start with a vector that begins with A. So we know the velocity of A with respect to B. And then I'm going to add it, and the next one I'm going to add has to start where this one ended. So it's got to start with a B. And I know that this goes to C. This is the velocity of B with respect to C. And if I want to get the D, A with respect to D, then I'm going to, again, start with where this left off and end up with D. So that is, these three vectors added up will give you the velocity of A with respect to D. Okay, well, what if we instead wanted to know the velocity of A? Oh, let's change that. What if we wanted to know the velocity of D with respect to B? How would we get the velocity of D with respect to B? Well, again, we know these three quantities. But to know these three quantities means that we also know the reverse. So I know the velocity of B with respect to A. It's just the negative of this. I know the velocity of C with respect to B. It's just the negative of this vector. And I know the velocity of D with respect to C. It's just the negative of that. So I'm going to start, to get the answer to this, I'm going to start with a D. And maybe I'll go to C. Again, I know that. That's just the opposite of that vector. Plus, it's the same magnitude, but in the exact opposite direction is what I mean by that. So this is the velocity of D with respect to C, but I want it with respect to B. And so I'm going to start where I left off. So I got to have a C here, and I'm going to put a B here. And so as long as the two bookends of these guys are these, and these link up, then the relative velocity should be true. So that's how you do that. Let me give you a practical example of this, or at least an example of this. Let's say that you have a river that's flowing this way at 2 meters per second. Let's say eastward. Now what I mean is that the water is flowing 2 meters per second relative to the earth. And so I'll write that as the velocity of the water with respect to the earth is 2 meters per second eastward. Okay, now you're going to row a boat, and you're going to row a boat, you're always going to point it due north. And let's say that you row that at 2 meters per second as well, so 2 meters per second northward. So that's the velocity of the boat relative to the water. And that's 2 meters per second northward. Okay, well, supposing you wanted to know what the velocity of the boat would be relative to the earth. Put some vectors on these. Well, the velocity of the boat relative to the earth is, I'll start with B, but I don't know the velocity of the boat relative to the earth, but I do know it relative to the water. So I'm going to do this, plus the velocity. Now I want to start with water, and since I end it with water, and I'm going to go to the water relative to the earth. Well, there you have it. That's going to get me my velocity of the boat relative to the earth. So that would be, I'm adding this vector, boat relative to the water, so I'm adding that vector. That's 2 meters per second. Plus the velocity of the water relative to the earth, so that's 2 meters per second eastward. So here is your resultant vector. That resultant vector is the velocity of the boat relative to the earth. If you do that out, if you check that out, it's going to be the square root of 2 times 2 meters per second, and it will be 45 degrees north of east. So that's how you work out relative velocity problems. You just link them like that, and you will get them right. All right. Thank you.